discuss the two aspects. So let us consider those two aspects first through our data, through our output. Then I will be coming back to these slides. Okay. So now we are considering whether our data is containing outliers or not. Okay. If you check the sales of the data for the first quarter, here the mean is 81,000, right? But when we consider the median is 71.50, as well as the 5% trimmed mean is also 72.48. So here, when you look for these values, you find that there is a big gap, big difference between mean and 5% trimmed mean and mean and median, right? There's a big gap, right? So here the gap is large. Now we consider the second part. Here, the mean is 72.43. You can have 5% trimmed mean is 72.48, approximately same, and median is 73, very near to 72.5. Okay, so here the difference between mean and 5% trimmed mean and median is relatively small, is very small, right? So from here we can have a basic idea that outliers or extreme value may be there in the data related to the first quarter, and the second quarter we may not have that problem that is known as outlier or extreme value. So the first thing is by comparing these two things. Hopefully these things are clear to all of you. Okay, right? So this is one of the methods. Now we go to the robust estimator, right? We go for the robust estimator. In the first quarter, the M estimators values that are being suggested are on the scale or on the values nearing to 72, 72, 72. And if we compare the mean, there is a major difference, right? So there's a major difference between mean and outlier. So we know that mean is badly affected by outlier, and 5%, and these M estimators are not at all affected by the outlier or extreme value. So we can always say that there are chances of outliers for the first quarter. In the second quarter, the mean is 72.43, and all the M estimator value, all the robust estimators value are also on the same range, right? So there is not much of the difference. So we can say outliers might not be there in the second quarter. Okay. Now, here SPSS has this provision. It provides, if you put the option of outlier, it provides us top 4 and bottom 4 values. So if we go with this, here the highest value is 610, and the next value is 90. Other values are 88, 88, 87, right? Not much of the gap. But here 610 is very much different from 90. So the chances of outliers might be there. For the lower side, the minimum value is 54. The next minimum is 57. Not much of the difference. So we can say outlier or extreme values are not there for the lower part. Outliers or extreme values are there only for the upper part for the first quarter. Now in the second quarter, we have values. The highest value is 92. Then we have 99, 89, right? Not much of the difference. So outliers are not there, right? But when we come to the lower side, the minimum value is 48. The next minimum value is 56. So there is a gap, right? Now, if we consider this gap, 610 and 90, this gap appears to be huge. Since this gap appears to be huge, so we can take this gap as extreme value. Okay, we can take this gap as extreme value. Here also we are having a gap, but this gap is there, but not that much substantial gap. So we can take this gap as an outlier, that is circle. Okay, that is being denoted by circle. So now here I am explaining both the concepts, extreme values as well as an outlier. Hopefully these things are clear to all of you. And this is a histogram, you can check. This is box plot, and you can see that there is an observation at case number 55. There is an observation at case number 55, which is having value 610, and it is being denoted by radius, denoted by star. But if we go for the next case, for the Q2 data, there is also a value that goes beyond the leaves, right? But here the gap is not that much, and circle is being used. So the software is suggesting that this value, which is being situated at case number 48, incidentally the value is also 48, can be taken as an outlier. But this value that is being situated at case number 55 is having a big value that should be taken as an outlier. Right? So this is a discussion that is related to outlier. Now what we can do? We can remove the outliers, or we can use some standardization by converting everything on the standardized scale. So this is a discussion that we have related to outliers. So any question? How would you detect the outlier, and how you would examine outliers is there or not, and what would we do if outliers are there? So hopefully these things are clear to all of you. Or any question? Okay. Now I'm changing the screen. So outliers we have discussed. Now we are coming to the last assumption, right? That is the assumption of the norm. There are other approaches also, like here, just a moment. We have actually considered the univariate outlier. Outliers can be bivariate. Okay. How will we process the data? That I will be explaining, right? And the other thing is the outlier can be bivariate also, right? Here I am primarily discussing the univariate. How that can be done? The data is being plotted on a scatter plot. This is x1 and this is x2. Right? So any value, if any value that is lie outside this dominance is being taken as an outlier when we have the bivariate case, right? So in this manner, we can examine whether outliers are there for the bivariate case or not. Here we use the scatter diagram that I will be showing you when we study the regression, right? So this is another method. I'm doing, I will be explaining what will be done. That I will be explaining later on. So before that, for that, I am also taking up the last issue that is related to normality, because it is very much related to the topic that I am going to cover. So in a number of tools that we are going to apply, the normality is required. So if there is significant variation from the normality, there will be a question mark on the validity of some statistical test. How normality can be examined? The one method is mean. There won't be much difference between mean and median. The absolute value of skewness would be approximate 0. Absolute value of kurtosis would be approximately 3. Histogram and frequency curve would be a bell-shaped curve. Stem and leaf would also be a bell-shaped curve, but it would be horizontal. Box plot, I have discussed. If our distribution is normal, then these two boxes would be similar equals to each other, and these two whiskers should also be equals to each other. Right? So this is the method by which we can examine the box plot. Now the last method, right? They are the visualization method. After that, we have some testing part also that I will be showing later on. So how the normal probability plots can be, normal PP plots can be, or normal QQ plots can be drawn. Here on the x-axis, we have observed values. And on the y-axis, we have expected values or assuming normality. Right? Means on the y-axis, we have values that should be there if normal is there. And if we draw the curve, so this 45-degree line is important because this 45-degree line represents that here the observed values and the estimated or expected value from the normal are the same. Right? So if our points lie on this 45-degree line, we can say our data is normal. And if points are much deviated from this line, then our data is not normal. So this is one of the methods. Other methods are also there that I will be discussing along with the testing part, that is Kolmogorov-Smirnov and the Shaparov-Wells, right? There are other tests also like an Anderson-Darling test, right? Jack-Barra test. So number of tests are there that are being used to examine the normality, okay? That I will be taking later on, okay? So this is related to the normality examination. Now I will be showing you all these things. So any question up to this point, or things are clear to all of you? Any question? Okay. Now what if our data has certain issues, then what should be done? I'm changing my screen. Okay. So if you people have gone through, since I'm here demonstrating through SPSS, so I'm taking the help of SPSS. And if you use some other software or languages, you can use the other thing, but the concept remains the same. Okay. Even in the Python also, we use these type of functions, right? Suppose this is our data. Now, we normally use this drop menu, that is the analyze, right? That contains all the tools. But there is one more option, that is transform, that can be used for the data processing purpose. Like if we have missing observations, right? And we want to do missing value imputation, we can take the function that is replace missing value. Suppose missing values are there in the sales of the data in the fourth quarter, right? So I will take that. Okay. Now what it does not overwrite the original variable. It leaves the original variable as it is, right? And create a new variable. So it is creating a new variable. And what method is being used? Default method is all the missing observation would be replaced by series mean. There are other methods also that we have discussed, right? Mean of the nearby point, median, in linear interpretation, linear trend, right? So normally mean and these first three are being used for the cross-sectional data. The last two are being used for the longitudinal data. So if we put OK, then a new variable would be created. Though it is not required here since we don't have missing observation. So here a new variable is being created. You must be seeing Q4 cell 1. Since there is no missing observation, so there won't be any change. Okay. So by this manner, we can do missing value imputation. The second thing is, suppose outliers are there. So how that can be done? We can calculate the range and we can go with the transform. And in the transform, we can have compute variables, right? So we can create a new variable. Suppose Q3 is there. So we can have Q3 underscore new. And here we can put the formula, right? Here we will be taking only those values that are in the range only, right? So in this manner, we can put the formula here, like suppose we take this, right? And it will be less than, suppose we want to take only those values that are below 90, right? So we can this. So a new variable would be created where all the values would be below 90. In the same manner, all the values that are greater than 90. So in this manner, we can have a new variable also, right? So this is another example of data screening. And if our data is not normal, we can have the normal data also. We can convert them into the Z scale. How that can be done? We go to analyze, then we go to descriptive. In the descriptive statistics, we have an option of descriptive. And suppose we want the standardized values. We want to convert that into the Z, right? It can be done by the transform also, but it is the direct method. And if we press OK, you will be seeing a new variable, that is the standardized Q4 cell, right? Here the values are being converted into a Z scale. So all these things can be done, right? So that it can be converted into Z and that normality can be tried. So any question related to this aspect? Is it okay? Okay, right. Now, there is one more method, like in this output also, I will be sharing that. You can always check whether normality is there or not. I am showing you this part. Like the Q1 cell value. Skewness is 7.5. Kurtosis is 57, widely separated from 0 and 3. But for the Q2, skewness is very near to 0, though kurtosis is not, but it can be taken as normality. Right? This part I am discussing later on. Like here that I have discussed, the normal quantile plot. This is a 45-degree line. And here you can check points are widely separated from this 45-degree line. So Q1 cell should not be taken as a normal data. But if we go with the Q2 cell, right? Here, as you can check, most of the points are on this 45-degree line. So it can be taken as a normal data. And here box and plot also shows that these two boxes are near about similar to each other. And these two whiskers are also near about similar to each other, right? So this is the normality examination that we have discussed. I am going a bit fast, right? So that we have sufficient time to discuss the other aspects also. So any question up to this point? Any question, or the normality examination is clear to all of you? I will be showing this testing part. Right? I will be showing this. Is it clear to up to this point? Okay. Okay. So now I am taking, just a moment. This, I will be sharing these slides with you. Okay. So now I am going to start the related chapter that was uh, uh, means today and tomorrow. I will be taking these points. Significance testing. Right? Why the word significance is there? Right? there is other name that is a testing of hypothesis that I will be introducing later on. Why the significance testing? There is a population. This is a population. And from this population, we have drawn a sample. So though we believe that this sample is a replica of the population, but in the real sense, it can never be a perfect replica. So there will be some difference between the sample results and the population results. There will always be some difference in the results. What we do, we examine whether this difference is small or this difference is substantial. So this difference is insignificant. I'm now using a technical word, or this difference is substantial or significant. So we always have a difference. We only examine whether this difference is significant or not. How that can be done? For that, we propose a hypothesis. Okay, and this hypothesis is being tested. Right? So the related name is hypothesis testing or testing of the hypothesis. Okay, so just a brush up of the concept. The totality related to the problem is known as population, and the study of the population is census. Sample is a representative subset of the population, and if we take up the data from the sample only, that is known as sample survey. And here I am discussing the concept that is the statistical inference, means inferring about the population on the basis of sample. It has two aspects. One is estimation that I am not taking here. And the second aspect that I have going to discuss is significance testing or the testing of hypothesis. So the first word is hypothesis. Remember, hypothesis is not an assumption, right? You should never say that hypothesis is an assumption. Hypothesis is a positive declaration, perception, claim, assertion, or conjecture about the population. Means there should be some thing in the base of that thing, right? Then that thing is known as a hypothesis. So hypothesis is different from an assumption. Assumption can be anything, but hypothesis should have something in support of that. So all the researchers who are here, they know the importance of literature review. So actually the literature review provides us the base on which we develop the hypothesis. In the same manner, all the business students who are attending the class, right? From the business or from the industry or from the organization that we are considering, we get the hypothesis. So remember, hypothesis is not an assumption, and we examine hypothesis for the correctness on the basis of sample data, right? So we examine whether there is a significant difference between the population values and sample values. How that can be done? It can be done by proposing a test. Test is actually a statistical rule that I will be explaining, right? And here we have two types of hypothesis. I am taking an example. One is a null hypothesis, hypothesis to be tested that assumes no relationship or no difference. And other one is the alternative hypothesis, right? So now I am taking some examples of this hypothesis, or is how the hypothesis are being constructed, right? Then I am going forward. Okay. So the data, that is the Ventura data. Now I am taking certain questions and we will be discussing what can be those hypotheses. So the first is, there is a claim that average sale in the first quarter is 75,000. This is the claim, right? This is the first question that we are going to examine. Second question is, there is a claim or there is a perception that rural outlets are giving higher sales as compared to urban outlets. The next question is, remember in the case, there was a mention of advertisement. Advertisement is being used at the end of the first quarter. We want to examine whether advertisement is a success, right? And this success is immediate. So we will be examining whether there is an increase in sales as we go from Q1 to Q2. And the last perception that we are going to examine here is there's a perception or claim that all 4 regions have equal potential of sale. Or they are showing the similar amount of sales. So these are the claims or the perceptions are there. Okay. Now I am taking one by one. So here the claim is 75. Now here we propose 2 types of hypotheses. One is H naught, that is known as null hypothesis. So null means it assumes no difference. Since this hypothesis is on the average value, so we write it as mu equals to 75. Remember, we use Greek letters so to represent the population value. So remember, the hypothesis would always be on the population value only, not the sample value, right? Because sample value is known, so it cannot be an hypothesis. So H naught is mu equals to 75. Now we are considering alternative hypothesis H1. As the binary number suggests, H1 is opposite to H naught, right? So it can take any form. Suppose someone says, no, you are mentioning a very high value. Right? This 75 value is a very high value. This is a very high claim. It won't be there. So that person is indicating that sales are substantially below 75%. So this direction is less than. Right? In the same manner, some other person can say, no, you are reporting a low value. Means our outlets are very fertile, or our outlets are giving very high value, and you are mentioning a low value. So here indication is towards the higher side. So mu is greater than 75. Remember, H1 or alternative is opposite to the null hypothesis. Now, the third case can be means the first 2 gives the direction. The next case is the person say, no, it can't be 75, right? But that we are not clear whether greater than 75 or less than 75. So here hypothesis can be mu is not equals to 75. Right? These 2 are known as one-sided or one-tail hypothesis. The first one is left, the second one is right, and this is the two-sided. Now, here only one sample is required, so to perform the test. So these type of tests are known as one sample test. Okay. The most basic one. Now I am coming to the second problem. Here, as you can see, there is a comparison. Right? We are comparing rural outlets with the urban outlets. Right? So we are considering the difference. Okay. So here hypothesis can be mu r minus mu urban equals to 0. But it is better to write in the form of mu r equals to mu u, right? Why we do? Because H naught proposes that there should not be any difference. H naught is to be nullified. So it proposes no difference, right? So if we put the first thing, right, in the form of language, the first statement is claim is right. And here they represent claim is wrong. Okay. And here this would be claim is wrong. So the hypotheses are not being made as per the claim. Hypothesis consider both the things, claim as well as the concept also. Since H naught assumes no difference, so H naught should be mu R equals to mu U. So mu R is the average sale of the rural area and mu U is the average sale of the urban area. Now H1 can be anything like that we have discussed earlier. So H1 can be mu R greater than mu U, mu R can be less than mu U, mu R cannot be cannot be equals to mu U. But here, as per the language, it should be mu R is greater than mu U. So if this is the thing, then we say that claim is right. Now, this hypothesis consider two samples. So this is known as two sample tests. Okay. Now we are coming to the third one. Here also we are comparing Q1 and Q2. So H naught can be average sale of the second quarter is equal to average sale of the first quarter as the concept demand. Means there is no substantial difference from Q1 to Q2. So we can say no difference, no significant difference. So we can say that advertisement is not a success, provided all other things remains the same. And what can be what could be H1? That there is an increase, means advertisement is a success. So mu Q2 is greater than mu Q1. Average sale of the second quarter is greater than average sale of the first quarter. This is also known as two samples. Why two samples? We require one sample from the Q1 and another sample from Q2. Now, what is the difference between these two? Here, the units that belongs to one sample, that the rural outlet, may not belong to the urban outlet. So two samples are being drawn independently. Two samples are different from each other, right? So this is known as two sample or two independent sample test. This test is known as two independent sample. Why here? For a better comparison, we should be comparing outlet 1 pre-position, outlet 1 post-position, outlet 5 pre-position, and outlet 5 post-position. So here we are selecting only one outlet and we are taking pre-observation before in the form of Q1 and post-observation in the form of Q2. So this is known as two sample or two dependent sample test. This is also known as pair test or pair T test. Okay, right? So in two sample case, we have two options. And the last one, since here we have more than two regions and all regions are independent, right? So we propose the hypothesis is as mu north equals to mu east equals to mu west equals to mu south, right? Means claim is right. There is no difference. And for H1, even if mu and mu E, mu W are all different, then H naught won't be there. But even if mu and mu E and mu W are same, but mu S is different, then H naught cannot be there. So there are a number of cases that are going to be opposite to H naught. So we write that at least one mu I is different. And this test is known as K independent sample test or ANOVA. Okay, so these are the tests. Now all these tests requires an assumption. So all these tests requires an assumption, and that assumption is that the population from where samples are drawn should follow normal distribution. Okay, so if answer is yes, we will be going with parametric test, and if answer is no, we will be going with non-parametric test. Okay, right? So this is the concept of testing. Now, how that can be done? We have two values. One is the value of the population, other is the value of sample statistic. Let us be denoted by T or S. We consider the difference. If this difference is small, right, then both can be taken as the same. So we can say that we accept H naught. We don't reject H naught. But if this difference is large, right, then we can say that there won't be any difference. So we reject H naught. Now, if difference is small, it means there are high chances of such a difference. Because difference is small. Now, this difference is large. Means here we have low chances of such a big difference. Okay. Now, chances means the probability. So there are high probability of such a difference. This probability is known as p-value. This is known as p-value. This is being denoted by p-value. Means p-value should be large in the first case. Here the chances is low. So here we can say that p-value is low. Right? So how that can be done? Normally we go with the 5% level of significance. So we compare p-value with this value. So if p-value is greater than this 5%, 0.05, we consider it to be a large p-value. So we don't reject, we accept the hypothesis. And if the p-value is small, since p-value is very small, means the chances of such a big difference is low, then we reject H naught. Means there is a significant difference. I am not going in the technical detail that we teach to statistics students. I am explaining it just to you people have some idea. Right? Here, everything is there in the notes. So you can go with the notes also. So this is the concept of the testing. Right? I have earlier explained the parametric is the non-parametric part, right? Means whether the distribution is normal. And then I have also explained the concept of the p-value in a non-technical manner. Okay. So any question up to this point? Any question? Or things are clear? This concept would remain applicable whatever the tool you will use. Any question or it is clear? Okay. So which concept is not clear? Can Amit or Shubham, can you write? Okay, that this p-value concept. Hello. Okay, parametric means if normality assumptions is being made, right? So if normality assumption is there, right? So we will be using the parametric test. So all the tests that I have mentioned here, that is a t-test, f-test, they belongs to this parametric test, right? Here, as you can follow the notes, parametric testing, population distribution is following normal distribution. Non-parametric, if normality assumptions cannot be made. And the parametric test that we are going to study can be z-test, t-test, right? That I have just introduced, difference of the pair t-test, independent sample t-test, and ANOVA, right? All these are the examples of the parametric test. Okay. So any other question? Is it okay? Or any other question?